Okay, so we're going to look at projectiles at any angle. So first of all, we've got a particle P projected from a point O on a horizontal plane with speed 28 meters per second with an angle of elevation 30 degrees. So that means that it's going 30 degrees above the ground. After projection, the particle moves freely under gravity until it strikes the plane at point A. Find the greatest height above the plane reached by P, the time of flight of P, and the distance O to A. So the distance O to A is in fact the range, as you might otherwise call it. Okay, so let's start by thinking about what's going on here. So we've got a particle projected, speed of 28 meters per second. We've got an angle of 30 degrees above the horizontal. What we want to do is get the components, horizontal and vertical, for this initial velocity. And then we're going to be able to use those to answer the other questions. So this component's opposite 30, so it's 28 sine 30, which is 14. This is 28 cos 30, which is equal to 14 root 3. Okay, so when we're talking about reaching the greatest height, that means this point here, at that point, the particle's travelling horizontally. That means that the vertical component of its velocity must be 0. So what we want to do is come up with some kind of equation that we can then solve to find, first of all, the time, and then from there, we'll actually be able to work out the greatest height. So let's start by saying u, y, because this is all to do with vertical at the moment, because we're talking about the time to reach this point and then also the height from there. So uy is 14. Vy, so the speed when we reach the greatest height, is 0 vertically. Obviously it's moving horizontally still, but vertically it is 0. The acceleration is minus 9.8 meters per second squared, and actually what we want to work out from there is sy, so the height at that point. So we can use an equation that connects those. So the equation that connects those is v squared is equal to u squared plus 2as. So we're going to have minus 9.8, oops, wrong one, 0 squared is 14 squared plus 2 times minus 9.8 s. And so that's the same as saying 0 is 196, subtract 19.6 s. So in other words, we can solve that and get s to be 10 meters. So actually we didn't need to find the time in that example, we could work out s directly. Okay, part B, the time of the flight. So the time of the flight is what we're trying to find, t. The time of flight is when we've reached the ground again. So when we reach the ground again, that is when sy, the vertical displacement and distance above the ground, is equal to 0. We've still got uy is 14. We've still got the acceleration is minus 9.8 meters per second squared. So we want to find an equation that connects those, which would be s equals ut add a half at squared. So 0 is equal to 14t minus 4.9 t squared. So that's a quadratic equation. So we're going to solve that to get two solutions. One is going to be when t is 0. That's going to come from factorising here. And the other solution is 14 over 4.9. which is about 2.86 seconds. So the answer to the question is the 2.86, because t equals 0 was where we were at the start. Okay, and in part C, we're trying to find the distance O to A. Well, the distance O to A, that's the horizontal displacement in that time period. So we've got t is 2.86. The horizontal velocity was 14 root 3 meters per second initially. And we're trying to find s. And we also know the acceleration is 0. So we're going to use the same equation, s equals ut, so half at squared. So sx is just going to be 14.3, sorry, 14 root 3, not 14.3. 14 root 3 times 2.86, add 0 because there's no acceleration. Okay, and then that comes to 69.3 meters, which is then our answer.